So, good day po. I am Ronan Chabarero from BSIT2AB and my group mates po. So, now po we're here po to discuss or to tackle all about firmware and its origin. So, basically, we will also discuss its origin or history, the examples, the types, the purpose of it, the purpose of firmware, and the evolution of it. So firmware, it is a type of software that is embedded directly in a piece of hardware to make the hardware work is as intended. So firmware is programmed by manufacturer and is installed on a digital device right in the factory, and all computing devices have firmware. Okay? So, ang ano po, yung firmware po is programming that is written to hardware device in volatile memory. When we say non-volatile memory is a form of static random access memory where the content is saved when a hardware device is turned off or loses its external power source. So, firmware is also installed directly onto piece of hardware during manufacturing. It is used to run user programs on the device then and can be thought as the software that enables hardware to run. It is also software program or set of instruction program or embedded on hardware device which provide low-level control for device-specific hardware. Sometimes the firmware provides some standardized operating environment or it acts like operating system. So other components can communicate with each other within the machine and perform their task easily. So, to conclude that, firmware po performs all monitoring, controls, and data manipulation function. It helps non-volatile devices. So, ayun yung definition of firmware.
Hi, I'm Matt Jovan Marquez, and now we are going to learn about the history of firmware. Firmware was first used in 1967 by Asher Abler as a bridge in between hardware and software. In this piece, Abler was referring to a novel category of computer that, from the user perspective, serve as a practical psychological goal distinct from that of conventional programs. The history of firmware dates back to the early days of computing. In the 1950s and 1960s, early computer systems were built using discrete transistors and diodes, and the firmware was often implemented using hardware logic. Originally, firmware was strictly written on ROM chips that allowed it to be cheap to manufacture and ensured it did not get deleted or tampered with. Programmable read-only memory (PROM) chips were also used instead of ROMs to store this type of data. However, using ROM and PROM to store firmware means that when a device firmware becomes outdated, it cannot be updated, only replaced. As technology advanced more rapidly, firmware started becoming outdated sooner. Before the hardware got worn down, manufacturers then switched to using erasable, programmable read-only memory (EPROM) chips, which allowed for firmware updates. But since EPROM chips were expensive to manufacture and time-consuming to program and update, firmware eventually evolves to flash memory chips, as they are cheap and easy to write and rewrite on.
Hi, so I'm Sheena Viale Oliveros, and so for the examples of firmware. So the first one here is the personal computer. So the firmware of a personal computer either BIOS or Unified Extensible Firmware Interface. So this comes embedded on a small memory chip on the computer's motherboard. And a computer's peripherals such as graphics and video cards also contain firmware. And then the next one here is the storage devices. So USB drives, hard drives, and other portable storage devices contain basic firmware that enable them to function with a computer. And then next one is mobile devices. So mobile phones, tablets, laptops, and other mobile devices all contain firmware that let the hardware work with various softwares. And then next, automotive. So automobile contain many embedded systems, sensors, and small computers that contain firmware that enables them to perform their designated tasks. And then next is home appliances. So dishwashers and washing machines are among the appliances that contain firmware. So the firmware helps the machine to communicate with a computer used to configure the machine settings and control its operation. And then last is smart cards. So smart cards have instructions embedded in a chip that provides the card's basic functionality such as authentication and encryption. And so that's just some of the examples of firmware.
Hi, my name is Lemon Dibadaan, and for now, let's talk about the types of firmware. And we have here the three types of firmware. So the first one is low-level firmware. The second one is high-level firmware. And the last one is subsystem firmware. There are many types of technology-specific firmware, but all firmware can generally be sorted into three categories based on the level of hardware integration. So the first one is low-level firmware. Low-level firmware is considered an intrinsic part of device hardware. This means you cannot overwrite or update low firmware. A device that contains a low-level firmware has one-time programmable memory. So the next one is high-level firmware. High-level firmware is a type of firmware that allows updates to the code. You typically encounter this type of firmware on the flash memory chips. High-level firmware is closer to the software than hardware because the code instructions are more complex than the low-level firmware. And the last part is subsystem firmware. Subsystem firmware is usually a part of an embedded system and reminiscence of high-level firmware for two reasons. So the first reason is you can update subsystem firmware. The last reason is the instruction of subsystem firmware are more complex than the low-level firmware. A great example of the subsystem firmware is the server power subsystems, which work almost independently from the server.
So, good morning. I'm Benedict, and I'll be discussing the topic of firmware, purpose of firmware. So, let's start. So, firmware, almost all electronic devices, beyond the simplest one, contain some firmware inside of them that controls the basic function of the hardware of that specific electronic device. So, firmware is installed directly on the piece of hardware during manufacturing. So, nakastore siya sa firmware is held on non-volatile memory devices such as ROM, EPROM, or flash memory. So, nakastore siya sa non-volatile memory or yung type ng storage that contains permanent content or hindi na di-delete kapag naka-turn off na. So, firmware is used to run the expected tasks on the devices that they are attached to and can be thought of as the software that enables the hardware to run. So, yung firmware natin is basically, ito yung summary. So, yung firmware is basically a set of instructions needed for certain devices to perform the task that they were made of. So, in simpler words, it is the programming that is responsible to run the machine. But unlike software, the firmware is not created to perform specific functions on the hardware. Rather, it is used to carry out the core function of the hardware. So, yung firmware is, pwede rin natin siyang masabing operating system ng mga electronic devices natin. But yung difference is, yung firmware is directly naka-attach dun sa hardware mismo natin ng electronic device. And wala siyang GUI, and etc. And naka-store din pala siya sa non-volatile memory. So, one example of firmware sa electronic device is television remote control. So, it contains a firmware, yung remote natin. So, yung firmware, pinomonitor niya yung buttons sa remote, yung LEDs, kung ano yung mga pinipindot natin sa remote. And then, he sends the data in the format that the television can understand. So, yung TV rin natin may firmware. So, it can understand the data na sinend ng remote natin and etc. So, different kind of firmwares varies on different kinds of electronic devices. So, most of the devices that we are using today can be referred to as a computer-like system on its own, as they contain their own hardware and firmware. So, yung mga electronic device natin is like a mini computer. Kasi meron na silang hardware, tapos yung firmware na is yung customize nila. So, but digital services are undergoing frequent changes because the process of progress is a never-ending one. So, new products are introduced to the market and are packed with newer technologies and better functionalities. So, by merely updating the firmware, your existing device will become capable enough to compete with the newer product, giving you the latest functionalities on the same hardware. So, I'll explain itong updating the firmware. So, compared before na yung firmware natin is cannot be changed, one nakalagay na sa devices. So, ayan yung mga type of firmware, yung mga older electronic devices natin. Pero now, we have firmwares na pwedeng ma-update. For example is BIOS on computer. So, ngayon, pwede na siyang i-update para yung mga CPU yung mga bagong CPU is mag-work pa rin sa mga lumang motherboard. And that's one example. So, yung benefit nga ng pag-update ng firmware is we're able to fix bugs, imperfection in the firmware. So, instead na magpalit tayo ng device, ng hardware, we can just update the firmware to catch up on the changes in our technologies. Ayun, so, napaka-important ng firmware and continue pa rin pag-develop niya hanggang ngayon. And next is my groupmate will discuss the BIOS or one type of firmware na makikita natin sa computer. That's all.
So I'm going to discuss the BIOS or the Basic Input-Output System. So BIOS is a firmware code run by various systems like IBM-compatible PC. So this contains computer settings and this includes hard drives, RAM speeds, boot order, and etc. So this runs when the computer is turned on. Next is it initializes several motherboard components and peripherals. So these peripherals including are processors and caches, chipset, memory, graphics controller, mass storage controller, and various input-output controllers. And finally, it loads the bootloader for the operating system and transfer controls through it. We have the four functions of BIOS. So we have the POST or the Power on Self-Test, Bootstrap Loader, software drivers, the complementary metal oxide semiconductor or the CMOS setup. So for the POST, this tests the hardware of the computer before loading the OS. Next is the Bootstrap Loader. So this locates the OS. So alternatively called bootstrapping, bootloader, or boot program. A bootstrap loader is a program that resides on the computer's EEPROM, ROM, and another non-volatile memory. Next is for the software or drivers. So this locates the software and drivers that interface with the OS once running. Next is the complementary metal oxide semiconductor setup. So this is a configuration program that enables users to alter hardware and system settings. So CMOS is the name for BIOS, non-volatile memory. Today, many manufacturers produce motherboards with BIOS chips in them. So some examples are the following. So we have the AMI, ASUS, Foxconn, HP or Hewlett-Packard, and the Rycoh. So knowing the motherboard manufacturer is important because users may want to update their BIOS and chipset drivers. So the drivers that enable the OS to work with other devices in the computer, such as a video card, to the most recent versions. So driver updates may improve computer performance or patch recent BIOS level security vulnerabilities. So each manufacturer has a unique way of updating these drivers.